Friends, here I am talking about glycosides. Generally, glycosides are the compound which is derived from the replacement of the hydrogen atom of the cyclic hemiacetal by an organic radicals. So, as we know that glycosides are made up from two parts. First part is aglycan part and the second part is sugar part. So aglycan part is responsible for the therapeutic activity of the glycosides and sugar part is responsible for the pharmacokinetic activity of this particular glycoside like solubility, potency, etc. Classification of glycosides. So there are different types of glycosides. First one is cardioglycosides. It include digoxin, digitoxin, etc. Second is anthraquinone glycosides like uh, cyanosides and cascarosides and aloin, etc. Now, saponin glycoside, it is further divided into two categories. First one is steroidal saponin and second is terpene saponin. Steroidal saponin it contains diazenin and ginsenoside and triterpene saponin is glycyrrhizin. Next is cyanogenetic glycoside. There are some examples of cyanogenetic glycoside like amygdalin, prunasin, linamarin, etc. Then isothiocyanate glycoside is Syngrin. Isothiocyanate glycoside is Syngrin. Now flavonoid glycosides, rutin, quercetin, and rhamnolitic. Coumarin glycosides are psoralen, khalin, bisnadine, bergaptine, and xanthotoxin. Phenolic glycosides include arbutin. Phenolic glycosides include arbutin. Aldehyde glycosides include vanillosides. And last is alcohol glycoside like salicin. Now we move on cardiac glycosides. As we know the term cardiac glycoside, the glycoside which is used in the heart disease are called cardiac glycosides. Okay, so generally they were used as a poison in the medial travel by both African and South American natives for the preparation of other lethal arrow and spear poison for use in fighting as well as hunting. In 1785, a Scottish physician William Bathering first introduced the use of digitalis in heart therapy, and that is why these are also called as digitalis glycosides. Means firstly these glycosides were used in the heart therapy and they were obtained from the digitalis that is called foxglove. That's why they also called digitalis glycoside. Cardioglycosides generally obtained from the leaves of digitalis purpurea which have been used for more than 100 years under the name of foxglove. The main glycosides that are clinically used are digitoxin, digoxin, and uabin. Digitoxin, digoxin, and uabin. Chemically, a glycoside consists of a glycone and genin attached with one or four molecules of sugar, as we discussed earlier. So there are some points which we have to understand about the cardiac glycosides. So all cardioglycosides have C17 position and alpha beta unsaturated 5-membered electron ring. And all cardioglycosides have 3 beta and 14 beta hydroxy groups. Deoxygenin has an additional 12 beta hydroxyl group and getoxygenin has 16 beta hydroxyl group. The unsaturated lactone ring and the 14 beta hydroxy group are both essential in cardiac activity. Friends, again repeat, 14 beta hydroxy group and lactone ring are responsible for the cardiac activity of this glycoside. Digitalis glycoside have 5-membered lactone ring and are C23 glycoside, and it is also called cardinolides, where cilia glycosides have 6-membered lactone ring and C24 glycoside, and this is called bufadinolides. So C23 glycosides, so Cadiz and Balges and legal test, where C24 or bufadinolides, so Lieberman sterol test. In cardiac glycoside, deoxy sugars like digitoxos are present which show Keller-Kiliani and passage reaction. Means these two tests are due to the presence of sugar, deoxy sugar, Keller-Kiliani and passage reaction. Now, chemical test. There are some tests for the cardiac glycoside like Baldes test. In this test, when cardiac glycoside is treated with sodium picarate, it gives the pink color. That is Baldes test. Legal test, when cardiac glycoside is treated with pyridine, sodium nitroprusside and sodium hydroxide solution, it gives pink color. Keller-Kiliani test, when cardiac glycoside is treated with ferric chloride FeCl3 and concentrate H2SO4, it gives red color. Cadiz reaction, when cardiac glycosides is treated with 3,5-dinitrobenzoic acid plus sodium hydroxide, give purple red color. Cadiz, now passage reaction, this is also called xanthohydrol test, and it gives the red color with the cardiac glycoside. Now mode of action of glycosides, glycosides act with two mechanisms. First one is positive inotropic effect. In this, there is the stimulation, the force of contraction of heart muscle, which increase the force of contraction of heart muscle, lead to increased cardiac output, decrease heart rate, decrease venous pressure, and decrease blood volume. Second one is modify, directly or indirectly modify the formation of conduction of electrical impulses in the myocardium, resulting in the reduction in the heart rate and conduction rate. These are the two mechanisms for the cardiac glycoside. Uses in congestive heart failure and in supraventricular arrhythmias. So this is some facts about the cardiac glycosides. Friends, we will meet again.